Automatic, Addison.
In this tutorial, we are going to learn how to use if-else statements in Python to make decisions. This is a core concept in robotics where your robot needs to decide its actions based on sensor inputs and internal states. So to begin, let's open a terminal window. Open your favorite code editor. I am going to open VS Code, but I'm going to open VS Code from my Python tutorials folder. So cd ~/documents Python tutorial. And to open VS Code, I'll type code space period. Let's clear our terminal. And let's open a new file. I'm going to call my new file robot_decision_making.py. Okay, and let's start by typing the following code: pound if else statement for robot movement. Obstacle detected equals true. If obstacle detected, we do print, open parentheses. I'm going to say stop or change direction, period. Let's save. And then else, print, open parentheses. And in single quotes, I'm going to type continue moving forward, period. Okay, so the value of obstacle detected is true. If obstacle detected is true, we print stop or change direction. So that's what we should get when we run this code. And we get it, stop or change direction, because the value of obstacle detected is true. So the first part of that if statement is the one that will execute. Now let's simulate a more complex decision. Let's go down to line 9, and I'm going to say using if for sensor-based conditions. So we're going to use elif to simulate a more complex decision. And this is very useful for handling different types of sensors. And I'm going to go down here and type sensor underscore reading. And let's assign a string to it called low underscore battery. Save. And underneath that, I'm going to say if sensor reading equals, let's say obstacle, colon, print, open parentheses, avoid obstacle. Add a period in there. Otherwise, elif, otherwise, sensor reading equals low battery. Have to put the colon at the end here. And we do print, open parentheses, return to charging station. Say else, print, open parentheses, normal operation, period. Save. So sensor reading, the value is low battery. If sensor reading is equal to obstacle, print avoid obstacle. Otherwise, if sensor reading is low battery, print return to charging station. Otherwise, if sensor reading is neither obstacle nor low battery, we go to normal operation. So because sensor reading is low battery, we should expect when we run this program to get this output, return to charging station. And let's see if we get it. I'm going to first clear my terminal so it's easy to see. And let's click play, and we get return to charging station. Very cool. So this script that we wrote helps a robot decide actions based on its sensor readings, whether to avoid obstacles, recharge its battery, or to proceed with normal tasks. We can also nest if-else statements to handle hierarchical decisions. Let's do that now. Let's go down here, type a comment. I'm going to say nested if-else for more detailed decision making. If sensor reading equals obstacle, colon, distance, assign the value 5, and let's just call this distance to obstacle in meters. Say if distance is less than 1, print immediate stop. Otherwise, let's go to else, print, open parentheses, prepare to change direction, period. Let's go back, else, print, continue exploration. So this approach lets our robot make more nuanced decisions based on the distance to an obstacle. So if the sensor reading is obstacle, this piece of code will execute. We assign the value of 5 to distance, and if distance is less than 1, which it's not, distance is 5, we would print immediate stop. Otherwise, if the distance is either 1 meter or greater, we would prepare to change direction. All right, but in this case, sensor reading value was set here, it's low battery. So sensor reading equals obstacle, this doesn't hold. So this piece of code is actually the one that will execute because the value of sensor reading is low battery. So when we run this code, we should expect output to the terminal, the string, continue exploration. And let's press play now. Continue exploration is what we get. Now let's clear. To manage multiple conditions simultaneously, like combining sensor checks and operational states, we use logical operators. Let's get some experience with that now. Type pound logical operators for complex conditions. And let's let battery underscore level equals 20. Say percentage here. Say if sensor reading equals obstacle and battery level is, let's say, greater than 50, colon, let's say print, open parentheses, navigate around obstacle. And otherwise, elif, sensor reading equals obstacle, and battery level less than or equal to 50. Print, let's do return to base for recharge, period. Otherwise, if none of these conditions hold, we do else statement, print, open parentheses, continue on current path, period. So let's see here. Battery level equals 20. If the sensor reading is equal to obstacle, battery level is greater than 50, which means we have a lot of battery, greater than 50%. We navigate around the obstacle. Otherwise, if the sensor reading shows an obstacle and we are low battery, meaning battery level less than 50%, we return to the base for recharge. If there's no obstacles, and if the battery level is high enough, we continue on current path. So if none of these conditions hold, either this or this, we just can keep doing what we are doing, which is continue on the current path. And let's press play to see what we get. And we continue on the current path right there because there is no obstacle right now because the sensor reading, the value of sensor reading is low battery. So this script demonstrates how our robot can decide whether to navigate around obstacles or return to the base for recharge based on its battery level. In this section, we're going to dive deeper into using if-elif statements in Python to handle multiple conditions more efficiently. This is important for making your programs smarter and more responsive to a range of inputs. So let's start by creating a new file called robot decision system, robot _decision _system.py. Let's X out of that and clear our terminal. It's already cleared. Okay. So if-elif statements allow our robot to evaluate multiple conditions and react appropriately, which is important for tasks like navigation and interaction. Let's look at an example here of a robot deciding how to move based on sensor data. So type our first comment, robot movement decision system. And here we are going to create a variable and assign the value of wall to it. Wall is a string. So obstacle underscore type equals and wall. And let's say if obstacle type is wall, colon. Let's turn around. Print turn around. Otherwise, elif obstacle type is, let's say, small quote, single quotes. Let's say small object, colon, print go over. Elif obstacle type equals gap, print stop, and find another path. Else print clear path, continue moving. Right? Let's play it. Turn around. So we get turn around because obstacle type is wall. So in this script, the robot checks the type of obstacle and decides its action. This if-elif chain stops checking after it finds a true condition. And in this case, true is when obstacle type is equal to wall. And so we print to the terminal, turn around. Okay, let's clear. And notice, just like here, just like we did in a previous example that I did in the tutorial, you can add compound conditions. So instead of just obstacle type equals wall, we could say obstacle type equals wall, and let's say battery levels greater than 20, or small object and battery levels less than 20. You can add any kind of condition right here to the if-elif statements. You can add compound conditions. And let's do that now rather than all the chit chat. So let's do battery level equals 20. And let's call this a, let's put a comment there, power aware robot decision system. And let's set battery level to 20, and let's say if obstacle type equals wall and battery level is greater than 20, we do print, open parentheses, turn around. Elif obstacle type equals small object. And battery level is greater than 10. Let's say print go over. Elif obstacle type equals gap. Print stop and find another path. Else print open parentheses low power return to base. Save. So if obstacle type equals wall and battery level is greater than 20, print turnaround. But based on the value of battery level is 20, okay, and the value of obstacle type is wall, so wall and 20. What do you think that we're going to get here? So wall and 20. We're going to pass this one. We're going to pass this one, pass this one. So the only thing that really is true with obstacle type being wall and battery level being equal to 20 is this else statement. So we should expect this low power return to base. That should be output when we run this. Let's press play and see if that's what we get. And we do. Low power return to base. Okay, let's begin our next section. So now we are going to take a look at implementing comparison operators. Comparison operators compare two values and return a Boolean value, either true or false. They're useful for directing the flow of logic in programs, particularly in if statements. So let's look at each of the primary comparison operators. We will create a new file. I'm going to call it comparison underscore operators .py. Okay, we have our new file here. And let's just go through them one at a time. So our first one is equal to. Say print, going to do 10 equals 10, colon, and let's do comma here, and then 10 equals, let's get some space here, equals 10. Okay, so 10 equals 10. And this should output, what should it output? Outputs true. Okay, and let's do next line. Let's do print 10 equals 5, colon, comma, 10 equals 5. This should output 10 equals 5. No, that's false. So this should output false. Save. Let's do not equal to. Do print 10. Let's do our string here. 10 not equal. So the not equal is that exclamation point and the equal sign. 10 not equal to 5. Okay. Comma. 10 not equal 5. Let's create some space so it's easy for you to see. Okay. And let's do another comparison operator, less than. So print 5 less than 10, comma. One thing I don't like about Visual Studio Code is it put all these prompts stuff get in the way of me seeing, but it is a good code editor, but it can be a bit annoying at sometimes. So 5 less than 10. Okay. All right. And let's do greater than. Let's just copy this and paste it below. 5 greater than 10. Okay, 5 greater than 10, and let's do 5 greater than 10. Okay, and let's do less than or equal to, which is our next one. Print 5 less than or equal to 5. 5 less than or equal to 5. And now let's also do greater than or equal to. And I'm going to do this. And let's make this 10 greater than. So we have greater than or equal to, 5. And let's do 10 greater than or equal to 5. So what should we get here? Let's do the play to run this. So 10 equals 10 is true. 10 equals 5 is false. 10 not equal to 5 is true. Is 5 less than 10? It is, so that's true. Is 5 greater than 10? That's false, so we put false. 5 less than or equal to 5, true. And 10 greater than or equal to 5 is true. So these examples show you how we can evaluate basic numerical comparisons. So how about for this next step, we apply these in a practical scenario, like a robotic sensor reading that determines if an action is needed. Let's create some space down here and let's do robot sensor threshold check. And let's do sensor underscore threshold equals 10 and sensor underscore reading equals 12. So if sensor reading is greater than or equal to sensor threshold, we print sensor threshold exceeded, take action. Otherwise, else, print sensor levels normal, no action required. All right, take a look at that closely. Sensor threshold is set to 10, sensor reading is set to 12. So if sensor reading is greater than or equal to the sensor threshold, it should say sensor threshold exceeded, take action. And that is in fact the case. So when we press play here, that's what we get. Sensor threshold exceeded, take action. And just note that comparison operators are not just limited to numbers. We can also see how they work with strings as well. And let's do that below here. String comparison. Let's do print, open parentheses, double quote, ABC. Less than DEF, single quote, colon. Now let's do a comma after this, and let's do ABC, and we're going to compare that to DEF. Okay, and we are saving. And what should we output that to? So ABC, the equivalent numerical values of ABC is actually, in fact, less than DEF. DEF have higher values when converted to numbers than ABC. So we should get true here. So this should output true. And let's see if that is in fact the case. It is. ABC less than DEF true. So this example demonstrates that ABC is less than DEF based on alphabetical order, similar to how words are ordered in the dictionary. That's it for this tutorial. Keep building.